In these slides, we're going to look at liquids dissolving in liquids and one of the most basic principles in solubility, which will be on the next slide. So before we get to that next slide, I want to remind you that when you mix liquids with liquids, we identify the solute as the liquid that's in the lesser quantity, and the solvent is the liquid in the greater quantity. So that's just a reminder. Now what this table has, it's divided solvents, so things that do dissolving, into two categories, polar and nonpolar. Now, I want you to notice what the polar compounds have in common is that they have an oxygen. So even with these polar solvents, even though they have hydrocarbons, which we know hydrocarbons are nonpolar from a previous chapter. When you add oxygens, it becomes polar. Now, one of my other textbooks identified a general idea. So general means it's not always true. And they said if you have one oxygen for every 3 carbons, then in general, it's going to be a polar substance. Now, I look at the polar solvents listed in your textbook, and water is definitely polar. Just memorize that. The other ones all have carbons and hydrogens, but then they have the oxygen, which then increases their polarity. The only one that seems to not follow the 1 to 3 rule is the methyl ethyl ketone. Now, so that must be one that's an exception and has to do with it being a ketone. But so it's included as a polar solvent. Now, I will tell you, for exam purposes, I'm not going to ask you the polar solvent that are the exception to how we're trying to learn it. But it's not a bad idea if you're taking more chemistry just to understand that we can have these usually things, but then there's some exceptions. Now, if I look at the nonpolar solvent, look, I have hydrocarbons. The first 3 are hydrocarbons. Carbon tetrachloride we talked about before. When carbon is surrounded by the same element, in this case 4-chlorine, that makes it nonpolar. Now, there's 2 here that the chloroform and the methylene chloride. So generally when I look at something, if you have carbon and then it has different elements, it's usually polar, but chloroform they have on the nonpolar side. So I think this is kind of an exception. And then methylene chloride, the same thing. This is kind of an exception. So those 2, while they are nonpolar solvents, they don't really, they're kind of on the outside of what we would normally expect. Again, while I'm not against having them here, chloroform's a pretty common solvent. On the exam, I'm going to try to ask you some of the foundational things like hydrocarbons, which are nonpolar. So I won't ask you that. Then if you look on the nonpolar side, the ethyl ether, this one has 4 carbons and only 1 oxygen. So it would be on the outside of this rule, which of the 1 oxygen for every 3 carbon. So we would predict from that rule that it would be nonpolar. So right now, all I need you to do is kind of look at these and see how they're classified as polar or nonpolar. Now let's look at this. This is a major general principle, and the rule is like dissolves like. Now, what does this mean? This means that the closer 2 substances are in polarity, the more likely they will dissolve with each other. So if you read the second sentence, so the first one just says, in order for a solute to dissolve in a solvent, they must have similar intermolecular forces. Okay? As a rule of thumb, polar solutes are soluble in polar solvents, and non-polar solutes are soluble in non-polar solvents. So I always think to myself, polar loves polar, they will mix. Non-polar loves non-polar, they will mix. But polar does not mix. And you're like, wait, you put a heart. But just a minute. It does not mix with polar. So those two will not mix. So like dissolves like. Keep that in your mind when we're talking about solubility. Like dissolves like. The closer two substances are in polarity, the more likely they will mix with each other. Now, when we're talking about liquids, we talk about the words miscible and immiscible. So it says two liquids that completely dissolve in each other are miscible. And you'll use this word in lab, miscible. So they're liquids that completely dissolve. Okay, two liquids that are not miscible are called immiscible. So these are ones that do not mix, like oil and water. And so as you're looking on the bottom, look at this chart. So if the solute is polar, in a polar solvent, it is miscible, like dissolves like. In a non-polar solvent, it is immiscible, like dissolves like. If you have a non-polar solute, it will be immiscible in a polar solvent and miscible in a non-polar solvent. So let's go to something we all know, oil in water, which these two, they do not mix, correct? And if they do not mix, it is because oil, let's stop that. Water, we know, is polar. You may not know very much about oil, but I know water is polar. So what would oil have to be? Non-polar, right? That's why they don't mix. Oil is a non-polar substance. Water is a polar substance, and so they won't mix with each other. Oftentimes in biological sciences, they don't say polar, non-polar. They say hydrophobic and hydrophilic. So hydrophobic means it doesn't like water. Chemicals that don't like water in general are non-polar chemicals, right? Because water is polar. Hydrophilic compounds, those tend to be things that those are things that like water. So they tend to be polar substances or even ionic substances. So let's look at, there's an illustration of that exactly. So they have your oil layer, and then you have your water layer, and it just says polar water and non-polar oil are immiscible liquids. They will not form a solution because to form a solution, you have to be homogeneous. And if you look at the oil layer, it's a hydrocarbon. Oils are hydrocarbons, and hydrocarbons are non-polar. What else can we tell by having the oil on the top? If you said that it's less dense, that is correct. By this observation, we would know that oil, is less dense than water. And water has a density of 1 gram per milliliter. And how we know that is because oil is the top layer. So less dense objects go to the top, more dense objects go to the bottom. All right, so with liquids, remember how we define solutes and solvents. start familiarizing yourself with some of the polar solvents and nonpolar and see, especially the ones that I said are not kind of outside our rules at this point, that you can maybe recognize how would I know that this was polar or nonpolar, and then remember the rule like dissolves like. Polar liquids will just mix uniformly with other polar liquids, and nonpolar liquids will mix with nonpolar liquids, but polar and nonpolar will not mix, just like oil and water.